Alright everyone, welcome to another Python video. This video, we're going to solve the anagram problem. We're going to create a function that checks if two string arguments are anagrams. The function should return true if the two strings are anagrams. Example, bored and robbed are anagrams. Or, sorry, I should say robed are anagrams. Jake and Jasper are not anagrams. And if you don't know what an anagram is, it's a word, phrase, or a name formed by rearranging letters of another, such as cinema formed from Iceland. In our solution today, we're only going to worry about words being anagrams. We're not going to worry about phrases. So we're going to write two solutions. Number one is the following. Solution one idea. The length of each string must be equal, then each letter must occur the same number of times, and all the letters must be within each other. Okay? So that's the solution that we're going to go with. And what I've done is just formed, let me just bring the other solution down. I formed my function here with some testing cases as well. I have variables result 1, 2, 3, 4, and we're hoping to get true, false, false, true when we output these values, okay? So, first and foremost, if the length of the string must be equal. If not, they're not anagrams. So let's do that right away. So we can say that if the length of word 1 doesn't equal length of word 2, then we can just simply return false. Not an anagram. Okay. Now, once we are in this section, we are now allowed to assume that, well, they have the same number of letters. Now we just have to determine if they have the same letters and same number of them. So here we're first, well, I want to look at all the numbers. All right, sorry, all the letters. Look through all the letters. And then we're going to do the following. Well, for character in word 1. Right now, I am traversing. I'm looking through each individual characters that can be found in word 1, and I'm calling them character. Okay. Now, we're going to do the following. We're going to say, well, if word 1 dot count character doesn't equal word 2 count character, I'm counting this character occurring in word 1, and I'm counting that same character occurring in word 2. And if the counts are mismatched, we don't have an anagram, so we get to return false. And just a reminder, by executing this return statement here, we get to exit our function early. Hence, we get to exit the loop early as well, almost like acting like a break. Okay? And we're going to do this for all the characters in word 1, because if they have the same length, we should be comparing at least enough characters so that we can compare the values of each. But once we have found the character that has different amount of count or a different number of frequency in the other word, we should have a non-anagram. But if we get through this for loop, without actually returning anything, we are safe to say the following. I'm going to indent this so that it is part of the else statement. We can return true. We were not able to prove that it is not an anagram. Therefore, we return true. So I'm just going to write true. Okay. Let us actually execute this code. We get true, false, false, true, and that was our expected output. Now, at some point, we might analyze this code and learn that it is not the most efficient way to do this, especially how we have a for loop and running a dot count method. Okay, so that is something to keep in mind from the solution. But here we go. We're going to look at solution 2 as well. I'm just going to copy this over. And these are going to use anagram function called 2. So let's create def anagram 2. Word 1, word 2. End of anagram 2. This one's going to be a little different. We're going to take advantage of some of the built-in functions in Python to help us out, and this is actually going to help us a bit. So here we go. We're going to do the following. We're going to say, well, first and foremost, if the length of the word 1 does not equal length of word 2, it cannot be a anagram, so we return false again. Otherwise, we're going to do the following. We're going to say word 1 is going to update itself with the sorted version of the word. And word 2 is going to be the sorted version of word 2. And just for our sake, actually, we're going to go list word 1 and list word 2 so that we're creating new variables instead of updating these arguments, because that would be better practice. All right. Sorted sorts a string lexicographically and stores each individual characters as items in a list. So that's what this function does. I'm just going to explain it like that. Therefore, we know that they have the same length. We know that these are what's it called? We know that these are the same length, and we know that if they're sorted, we should have same individual characters from beginning to end. So we're gonna use that as an advantage and write our next for loop. We're gonna say for location index I and the character found in the enumerate version of list word 1. Okay. Right, so we are now unpacking. Enumerate assigns an index value to each character or each item that we have found in our list, okay? And then we're going to do the following. We're going to say, well, if we're going to analyze if list underscore word 2 at location I doesn't equal the character that we're analyzing currently, then we know for sure that we don't have a anagram. So we're going to return false. Okay. And end of for loop. If we're able to get to the end without having this if statement occur, we can safely say true, we have an anagram. End of anagram 2. All right, let's execute our code. We're hoping to get true, false, false, true again. And we get true, false, false, true again. So now this is a little confusing. So let's see if we can look at some values here. We're gonna say print an f string of I is I, and I'm gonna copy this over. And we're gonna have many things printing out. We're gonna have character. And then we're gonna have list at I for list to I. And after that, I'm gonna write just the empty input statement here, just to show you what's happening at every iteration. Okay. So right now, our first program was finished. It gave us true, false, false, true. Right now, we're looking at board, okay? And it would probably have sorted board and Rob into its alphabetical order. So we have B and B. And the first, so it did not satisfy this condition. So we get to loop again. When we're indexing 1, we're comparing these on both character and list word 2 at I. So we get to continue. E is the same, O is the same, R is the same, and they were done. Okay, 1, 2, 3, 4, 5. We analyze all 5 characters aboard. Moving on, we have these characters now. Okay, we're now looking at Jake and Jasper. Okay, we're now going to say the following. Oh, nope, sorry. We're looking at hello and maybe, because Jake and Jasper was already false. We didn't need to go through the output of all this because the lengths are different. Now we're looking at E and A. Right here, the lowest character is A, lowest character is E. So when we were sorting these two strings, our very first items of each of our list are different. Therefore, we should be exiting that. Right. If for this cinema here, we were able to analyze A and A, C and C, E and E, I and I, M and M, N and N, and we got true, false, false, true. Right. So there you have it. This was another type of solution that we could have done for anagram where we have sorted each string. Now, a sorted function generates a list, so therefore we were using list, and we also got to use the function called enumerate, where we were able to assign a index value to each individual list items that we had, which I decided to call character. If you want to see what that looks like, what I can do is the following. I can go print f format, go is that. Okay. And then we can also look at each of our lists right here after they're created, just so that you can see what they are. Okay. Run our program. So when we were working with board, it was able to sort each characters like this into a list. Hello, and maybe it looks very different. So we already know that it's not an anagram. When we were looking at when we're looking at Jake and Jake, it doesn't even get here because the length are not equal. And then when we have cinema, we have the same list as well. And what it does is it creates an enumerate object. Okay, so we can't actually see what that looks like, but we do create an enumerate object, which we can use with variable unpacking in a for loop. Okay, so that was our two of our solutions that helped us solve if two words are anagram. I hope you enjoyed that video. The code will be posted on GitHub. Anyways, thank you for watching and stay classy.